My name's Michalina Kotwica. I work at IBM Poland. Uh, I I'm not actually a Rust developer at the moment. I worked in using Rust in at Intel, but I switched to IBM like last year. So today I'll be talking about manipulating ports and pseudo terminals. Uh, Actually, that's one of the things that I used Rust for at Intel. So, you know, uh, it doesn't sound really cool at first, but it turns out that Rust is a really cool tool for that, as I hope you will see. So first, I would like to tell you what's the plan of my presentation, like what will I tell you about serial ports and pseudo terminals. So firstly, I will show you how to do it like in the simplest C I can imagine, using Unix libraries in C. Well, actually a wrapper in Rust. Then something a little more abstract, a specialized library for serial ports. Then we'll go asynchronous because I heard that you've already had a nice presentation by Bartek on asynchronous execution in Rust. Then to a little more advanced asynchronous library, and then some extras to boost up your app so that it, you know, does stuff with the serial port, because just accessing it isn't like cool enough. So okay, first if you look up hardware bindings and stuff like that, you will find lipudev library in crates registry. So really, it's not that different from C. You have to just match a subsystem of TTY, so serial ports. But it is tricky, I must say, because if we execute such a code, which is pretty self-explanatory, so give me all devices of subsystems TTY and show me their syspath. Okay, shit happens. Of course, it's C, so we need to install the C library using lipudev on Linux. We'll go cross-platform later on. Okay, but another problem is that it shows pretty much every TTY device, even the ones that aren't actually available on your machine. Like on my laptop, the TTY0 S0 isn't even available. I can't even access it. So it's not really that useful. For that to be actually useful, you need to filter them on the kind of TTY port, you need to access its parent and check all kinds of weird stuff. So I wouldn't recommend that way unless you're a, Unix lover, and especially considering that it's not cross-platform at all. So we want something a little more abstract. Serial port library is what I call a very rusty lib, which encapsulates what you've just seen, but not the version you've just seen, but the real code that actually does all the filtering I told you about. And all that fancy stuff just turns into available ports method, which on my machine only yields a single PCI port, which is true because I only have that one single port. Then we can open it and write some lorem ipsum or something. And if I plug in some device, I can see that the bytes were sent. But while we're at Linux, we can actually use something a little more fancy, let's say, for our app. I don't think it works on Windows, unfortunately, but you can use serial port opening on Windows too, just behind the flag, because the name of the port is obviously different. It's COM1 or TTY-S4 is actually COM4, I think, on Windows by default. But on Unix systems, you can use something called virtual port or pseudo terminal. So you can make such a pair of ports in which the master port is a virtual thing in your program that you can write to, while the slave is an actual device that gets written to your file system, and you can read it or write to it from another program, which is pretty nice if you ask me, because you can make an alias to it and just throw some stuff there and read it from your app, and especially nice because you can pipe them, etc., etc. One of the things I like to use it for is multiplexing of ports. So if you have just a single port, like a simple cable, you can plug that one cable on that one port, but have multiple port devices behaving like they were real things, despite the fact that you only have one physical device. Okay, but there is a little bit of a problem with that serial port approach. It still works like in C, because it has no clone, no send, no sync, etc. So if we want to use threads with that, so for instance, reading and writing on that port at the same time, it's not really obvious how to do it. Of course, you can use arc and mutex, but deadlocks are possible, right? You can use some fancy C knowledge, so you can use the ports row fd and then make a file from that and just write to that file or something. But yeah, it's not really the Rusty way, right? We don't really want to do that. So what I would suggest is just looking for hardware asynchronous. We will find Myo serial library that operates on Myo, which is, I think it's an abbreviation from Metal IO. Basically, it's a huge event loop with lots of boilerplate, but it's absolutely zero cost, not multi-threaded, I think. And it uses your system specific event system pretty well, because whenever you're on Windows, Mac, or Linux, it always uses the one that is specific to your operating system. So pretty cool. It makes your port operation asynchronous, which is nice again, but it's not really the kind of code that we do want to write. If anybody here wrote any code in C or C++ using SDL library, which also has a huge event loop that does pretty much everything, then you know what I'm talking about. Like it wouldn't even fit on two screens. So I would need to show you at least 3 slides for that. So let's go to Tokio. I think, I hope most of you know what is Tokio. So it's a really fun asynchronous library with really fun features. For now, let's focus on Tokio serial. However, we will need Tokio util later on, so I will introduce it here already. We'll use some features from Tokio utils and from Tokio. So don't be bothered by the features here in the dependencies, and also don't be bothered by the alpha version of Tokio serial. Well, happens, considering that Tokio has just entered the O2 version not so long ago. So as you can see, that code is something that we do want to write. It's basically just creating our serial port and creating some codec for it, and just maybe you know what it is. It is iterating of a stream. So you get just a stream that you can iterate on, just like an iterator. Nothing sophisticated here. It's very easy to do. You don't even have to use an executor because of the Tokio main here that you can see. What is interesting, however, on this abstraction layer is the lines codec, because you see we take the serial port here and we put it into a serial lines codec frame, and that is something quite nice because it makes the port, let's say, wrapped with the protocol of the lines codec. So when we read it on stream, it's not reading bytes like in C, let's say, not reading bytes to the vector, but it's reading strings, actually, lines. Well, of course, it can yield errors because it can be too long for the buffer, for the internal buffer to fit in, etc., etc. But well, if you do know about that kind of stuff, you can utilize it to write an even simpler code. As you can see, the iterating of the lines is pretty much done in one line. Okay, 2 lines maybe. Pretty much like if you just read a file, but it's asynchronous now, and you can both read it and write it, especially if you have such a pair, as I told you before, of pseudo terminal and virtual terminal. So let's see how the codecs works, to see how to implement them. So codecs have encoder and decoder, which are basically just fancy terms for something that can put your items, they are called, your objects to bytes array or byte slice, and a decoder which can decode them back. So I think encoder is pretty self-explanatory. So you can encode and either get an error or no result. Decoder is a little more interesting, in fact, because it can it returns a result of option, and here is why. Because the serial port can be just in the middle of creating that object. So if we have our line codec, it means that there isn't any line separator in our buffer yet. So it's kind of tricky because it's the decoder that behaves like an iterator in our example. What is even more interesting about the decoder is its framed method that you've already seen. The framed method turns a decoder, which is also an encoder, so 2 traits at the same time, takes it and takes something that can be asynchronously read and written to. So something that's, for example, a serial port is, that kind of thing, and takes them to a frame structure, which is a stream and also a sync. So you can pretty much make many different syncs and streams from your serial ports, depending on the format that you specify. So we will now try to specify our own format. For that, we will use, of course, Serde, which is my lib of choice for Rust serialization, and a nice library called Tokio bin code. Why bin code? Well, because it's binary codecs. So it won't be JSON, it won't be YAML, it will be just binary data. And here is why I think bin code is a really nice tool for that. That's all the code that you need to make your own format of communication via a serial port. So you just annotate stuff with serialize and deserialize from Serde, which makes it possible to turn it to, you know, JSON, YAML, whatever you want. And then use bin codec for that type and frame it. And that's it. Then you can split such a frame into separate sync frame and stream frame. And that's all. You have sync and stream for the serial port, which only sends your message type. So it's 100% type safe unless you open your serial port more than once, which isn't even implicitly possible on Unix systems, because you know you need to set the flag of exclusivity to false. On Windows, I think it's possible. So you know you do need to worry about that, but that's I do want to worry about such simple things like not accessing the same port twice, not opening it, because as long as it only is open at once, my custom protocol is working just fine. Okay, and so now we have serial port communication via serial port asynchronously with our own format of messages. So what would we like to do next? I think we would like to be able to react to Control C, because we would like to terminate the program. But you know, reacting to a single future isn't really as useful as it would seem, because if you have a network connection, you don't really want to just close the program or something. What you usually want to do is send a signal to your partner first that you close the connection and then close it. And to do that, well, you can do it multiple times with multiple partners. So a single future won't just work that well. So we'll use a stream again, which is a big advantages for us. Because you can just take that sync and send it to a stream. So you take that stream on your serial port and sell all of the interruption stream, which just waits for any signal, any Unix signal of interruption. So Control C, Control plus C, and then every time it meets an interruption signal, it emits message close and sends it to the stream. And that's pretty much all of it. It's so as you can see, this is a complete program actually. Here you have main, here you have our custom bin code, and here you have Control C to close the connection with your partner. So it's not even 50 lines, I think. It's like more like 20, and it's fully featured. The only feature I like to use that is not here is to use shell commands. So like running bash remotely, because who doesn't like to write their own SSH? But that is another story, because while essentially it's the same, because essentially it's just making streams and syncs for std in and std out, but you know, pipes are engaged in that, etc., etc. So I decided I will not include it here. And besides, I think the features I've already showed you are, for me, would be enough to convince me that using using Rust in particular for serial port manipulation is a good choice technology-wise, rather than C or C++. So to summarize, you can now have your app support UART, USB, Bluetooth, networks, network connections, and many more things that serial ports are able to support. It's fully asynchronous. You have your own custom message protocol. You can handle Unix signals. It's totally zero cost and absolutely no boilerplate. We didn't even make any asynchronous context for Tokio.